Okay. Okay, so once again, very good afternoon all. So I hope my voice is audible to all. Anyone please reply once again if it is audible.
Yes, sir.
Yes, sir.
Okay. Okay. So in the last lecture, we have started the problems based on the calculation of the volumetric stress, volumetric strain, and the change in volume calculation. And in the previous lecture, I have given the list of the formulas for the uniaxial, biaxial, and the triaxial condition. In addition to that, whatever the formulas are required to find out the change in dimensions, the change in dimensions in the sense sometimes we have to calculate the change in length, sometimes we have to calculate the change in width, sometimes we have to calculate the change in height or change in depth. If such questions will be asked in the statement, then how to calculate that change in dimensions? So for that purpose, the list of the formulas, so total 6 formulas I have given to you in the yesterday's lecture, that is epsilon x is equal to epsilon y is equal to and epsilon z is equal to. So that 6 formulas are also very important to solve the numericals. And based on the uniaxial, biaxial and triaxial condition, in the previous lecture we have solved the 2 to 3 problems based on the volumetric strain calculations, that is EV we have calculated in the previous problem, and in addition to that we have calculated the change in volume, that is delta V. Okay, so 2 to 3 problems we have solved in the previous lecture, and one problem I have given just for your exercise purpose at your home. Many students, they have solved that particular problem and they have sent the answer to me. That change in volume is I think 200 mm cube. That value is positive means there is an increase in volume. If your given answer will be negative, for example minus 200 mm cube, means we can say that there is a decrease in volume. But as your answer is positive, then we can easily say that there is an increase in value. So many students have solved that particular numerical and they have sent answer to me for verification purpose, and accordingly I have given the replies to that respective student. But still some students, they have not sent uh, their solutions. So those who are sending their submission, I'm recording from my side. Those who are not sending, they will be absent for that particular exercise. So still those who have not sent, those who have not solved, again I'm giving the time up to today evening. So you have to solve it and you have to send that answers to me on the WhatsApp. Okay, so now based on this, one more problem, last problem we will take based on this particular type number 5, that is calculation of the volumetric stress, strain, change in volume and the change in dimension. The previous 3 problems whatever we have solved, in that we have calculated the volumetric strain and we have calculated the change in volume. So same parameters we have calculated in all the 3 problems, and as per the conditions we have used the formula of the uniaxial, biaxial and the triaxial. Okay, so now this is the last problem we will solve, and then we will move to the next type. Okay, so I will read the statement carefully. We will understand the statement first and then we will check what extra parameters we have to calculate and how there is a change in the statement, that also we have to understood through this particular new statement. Okay, let us see here. A bar of steel, a bar of steel 65 mm by 65 mm in section and 190 mm long. So 65 mm by 65 mm, these are the 2 dimensions are given, and 190 mm long, that means this 190 mm is the length separately they have mentioned, and 65 by 65 means this is the product of B into D. Sometimes the product will be given in the form of L into B into D, like that. But here the B into D, this product is separately mentioned and the length is separately mentioned. Okay, it's subjected to load of 290 kilonewton along longitudinal axis. So whatever the bar is given, that bar is subjected to the one force of 290 kilonewton along longitudinal axis and tensile load of 750 kilonewton, 500 kilonewton on lateral faces. So one force is given in longitudinal axis and remaining 2 forces are given in the lateral faces. For 750 and 500, they have given both are tensile. For longitudinal axis, whatever the 290 kilonewton is given, they have not mentioned whether it is tensile or whether it is compressive. If it is not mentioned, then also we have to consider it as a tensile. If there is a compressive load, then be specifically they are mentioning in the statement whether it is compressive or not. If it is not mentioned, then we have to take this as a tensile. Now please tell me, whatever the 290 kilonewton force is applied along longitudinal axis, it is in which direction then? X, Y or Z? It is in which direction? X, Y or Z? Yes, it is in which direction? X, Y or Z? Longitudinal axis. Whatever the simple problems we are solving, in that sometimes this word they are mentioning. What is longitudinal axis? So please keep in mind, and you can write down in your notebook also. Longitudinal means we have to consider this as a x-axis. So please write down this particular thing. Longitudinal axis is equal to x-axis. Longitudinal means it is horizontal, we have to consider. And whatever the lateral faces are there, whatever the lateral faces are there, that lateral faces we have to consider as a y, and another lateral face we have to consider as a z. So whatever the 290 kilonewton they have mentioned, that 290 will be considered as a x-axis force, and remaining two, that is 750 and 500 kilonewton, whatever they have mentioned on the lateral faces, that lateral faces we have to consider as a y and z. Why longitudinal will be the 290? Because in general, if we think about some simple problems, a one bar which is subjected to the tensile load of 290 kilonewton, this is the straightforward statement. बघा एक बार असतो आणि त्याच्यावर 50 किलोन्यूटनचा एक टेन्साइल फोर्स ऍक्ट झालेला आहे. तर आपण फिगर कशी करतो? हॉरिझॉन्टल फिगर करतो आणि तो फोर्स पण आपण कसा दाखवतो? हॉरिझॉन्टल दाखवतो. मीन्स इट इज अलोंग x axis. So similarly here also we have to apply that concept, that is longitudinal axis is equal to x axis, and remaining two lateral faces will be considered as a y and z. So this is the statement they have given. Then find the change in dimensions of the bar and change in volume. Change in dimensions means we have to calculate the change in length, change in width, change in depth, and in addition to that we have to calculate the change in volume, that is delta V. Okay, for that purpose, E, this is the constant parameter they have given, and mu is also given. Okay, so this is the statement. So what additional things they have asked in this statement? त्याच्यामध्ये एक्स्ट्रा काय विचारलंय तर पहिल्या दोन्ही ते तिन्ही प्रॉब्लेम मध्ये आपण चेंज इन व्हॉल्यूम हा पॅरामीटर प्रत्येकाला काढलेलाच आहे. बट इन ऍडिशन टू दॅट दे हॅव आस्क्ड चेंज इन dimensions, means delta L, delta B and delta D. So these three parameters also we have to calculate. Okay, so write this statement in your notebook, draw the three-dimensional figure, and first of all we will write all the given things. So first, length is equal to 190 mm, B is equal to D is equal to 65 mm. Okay, then longitudinal axis Px is equal to 290 kilonewton is equal to 290 into 10 raised to 3 Newton. And write down in your notebook also, longitudinal axis is equal to x axis and lateral faces is equal to y and z axis. Longitudinal axis is equal to x axis and lateral faces means y and z direction. Then Py, टू लॅटरल फेसेस, त्याच्यामध्ये दोन फोर्सेस दिले, एक 750 दिले आणि एक 500 घेतले. तर त्याच्यामध्ये आपण सिक्वेन्स फॉलो करायचा, एक्स वाय अँड झेड. एक्स इज सेपरेटली गिवन 290. आफ्टर दॅट व्हॉट एव्हर द 750 इज गिवन, दिस इज द वाय. 750 किलो न्यूटन इज इक्वल टू 750 into 10 raised to 3 Newton. And last is PZ, 500 kilonewton is equal to 500 into 10 raised to 3 Newton. 500 into 10 raised to 3 Newton. Okay. In addition to that, E they have given 200 into 10 raised to 3 Newton per mm square. Okay. Mu is mentioned 0.3, and we have to calculate the change in volume. We have to calculate change in length, change in width, and change in depth. So these are the 4 parameters we have to calculate. Also, we have to represent all the dimensions on the figure. So length is 190 mm, width is 65 mm, this is 65 mm. Okay, all the forces, 3-dimensional forces are there. So this will be the problem under the triaxial condition. This will be the problem under the triaxial condition. Okay, so sigma x we have to calculate. So for that purpose, we have to represent the px in left side and the right side, then py at the top side and bottom side, and pz, this is in inclined direction, this is pz. Okay, so px, py, and pz all are tensile. Longitudinal axis, they have not mentioned tensile, but we have to consider it as a tensile because compressive word they have not mentioned. And remaining two, tensile load of 750 and 500, they have mentioned. Therefore, we have to take this as it is, as a tensile load. Okay, so this is the statement, and as per the triaxial conditions, we have to use the formulas and we have to find out the answers. Now start your solution one by one and send your answers in the chat box immediately. So here I will write down the formula. As per triaxial condition, as per triaxial condition, EV is equal to sigma x plus sigma y plus sigma z divided by E in bracket 1 minus 2 mu. So first of all, we have to calculate the volumetric strain because we have to calculate the change in volume, and to calculate the change in volume, we have to calculate the EV. But again, we have to calculate the EV means we have to calculate the value of sigma x, sigma y, and sigma z. So one by one, sigma x is equal to px upon ax, sigma y is equal to py upon ay, and sigma z is equal to pz upon az. Okay, so px 290 into 10 raised to 3 divided by area. So here 65 into 65, that is B into D. Then next force is given 750 into 10 raised to 3 divided by, here we have to consider the cross sectional area as a L into B. So 190 into 65, and last PZ 500 into 10 raised to 3 divided by L into D means again 190 into 65. So one by one, you please do the calculations and send me the answers in the chat box immediately. Everyone has to do this calculation because now you are having the practice of this calculation. Sigma x, sigma y, and the sigma z. All forces are tensile, therefore need not require to consider any negative sign. All the stresses are positive. All the stresses are positive. So one by one, send me the answers. X, y, and z. You can write like this: sigma x, sigma y, and sigma z. Is the answers I have received from one, that is 68.63. I will write as a sigma x. 68.63 Newton per mm square. I want answer from each and every student. X, then sigma y 60.72 Newton per mm square, and sigma z, just I will check, 40.48. okay, 40.48 Newton per mm square. Okay, one by one, after calculation, send your answers in the chat box, or if you have calculated all the threes, you can send all the three simultaneously. Just for your verification, I have written the answers. 68.63 Newton per mm square, this is the sigma x value. 60.72, this is the sigma y value, and 40.48 Newton per mm square, this is the sigma z. Please verify your answers and check the calculations whether it is coming correct or not, because this calculation is very simple and the straightforward, but it is very important. जरी calculation simple असलं तरी पण ते important आहे, because if you made the mistake here only, your all the further calculation will be wrong. तुमचा इप्सिलॉन व्ही चुकणार आहे, डेल्टा व्ही चुकणार आहे, डेल्टा एल, डेल्टा बी, डेल्टा डी हे सगळे पुढचे पॅरामीटर तुमचे चुकणार आहेत जर तुम्ही सिग्मा एक्स, सिग्मा वाय and सिग्मा झेड कॅल्क्युलेशन मध्ये जर मिस्टेक केली तर. Okay, try to write down the units also in your notebook. Newton per mm square, that unit is also very important. Sometimes we are not having practice to write down the unit. काही वेळेला आपण फक्त व्हॅल्यूज लिहितो आणि युनिट लिहितच नाही. Separate marks are there for the unit also. Okay, so everybody is sending the answers and all the answers are same: 68.63, 60.72, 40.50 or 40.48 Newton per mm square. Calculate the answers. Okay, once we have calculated that, put that values in the epsilon v. Those who have calculated the sigma x, sigma y and sigma z, please put all the values in the above equation as per the triaxial conditions. Those who have not calculated, please calculate your answers and send in the chat box so I can verify all the answers. Okay, then put the value epsilon v is equal to sigma x 68.63 plus 60.72 plus 40.48 divided by e 200 into 10 raised to 3 in bracket 1 minus 2 into 0.3. So epsilon v, those who have calculated sigma x, sigma y and sigma z, they can calculate volumetric strain as per the triaxial condition, and you can represent your answer also in the chat box so I can verify. 3.39 into 10 raised to minus 4. Just I will write here 3.39 into 10 raised to minus 4. Others, please check your answer also. 3.39 into 10 raised to minus 4. This is the volumetric strain from the triaxial condition. 3.39 into 10 raised to minus 4. This is the as per the triaxial condition. Everyone has to calculate this. Those who have calculated sigma x, sigma, those who have not calculated still sigma x, sigma y and sigma z and not representing the answers in the chat box, immediately represent it so I can verify your answers. If calculated, then go further. Calculate epsilon v. 3.39 into 10 raised to minus 4. Yes, 3.39. All answers are same. Those who are calculating, all answers are same. 3.39 into 10 raised to minus 4. Now next step, we have to calculate the change in volume. So we are having one more formula of volumetric strain is equal to change in volume upon original volume is equal to change in volume divided by L into B into T. So volumetric strain 3.39 into 10 raised to minus 4 is equal to change in volume we have to calculate divided by 190 into 65 into 65. Therefore, change in volume. What is the answer? Change in volume.
Two 272.13 mm cube.
272.13.
30.
So the digits will be variable, no problem. What are the answers you got? You send in the chat box so I can verify all the answers. 272.13 mm cube. 272.13 or some of you have got the 272.66. It depends on digits you have considered for the calculations. No problem, that is also accepted. mm cube, this is the unit. 272.13 mm cube. The value is positive. Means we can say that after applying all the forces in the three direction, म्हणजे आन्सर पॉझिटिव्ह आले म्हणजे अर्थ असं काय की जरी तिन्ही डायरेक्शन मध्ये फोर्स अप्लाय झालेला असेल ऍज अ टेन्साईल व्हॉट एव्हर द चेंज इन व्हॉल्यूम इज टेकिंग प्लेस दॅट व्हॅल्यू इज पॉझिटिव्ह म्हणजे ओरिजिनल व्हॉल्यूम पेक्षा चेंज इन व्हॉल्यूम हा काय झालेला आहे इन्क्रीज झालेला आहे. देयर इज नो एनी कॉन्ट्रॅक्शन, देयर इज अ expansion of that particular bar. 272.13. Yes, all the answers are same. 272.13. Okay, if you have calculated the change in volume, now go for our change in dimensions calculations. So second things, change in dimensions. Change in dimensions. So epsilon x is equal to delta L upon L. So delta L value we have to calculate. Delta L काढण्यासाठी आपल्याला ओरिजिनल लेंथ माहिती आहे 190 mm, but epsilon x value is not known. Epsilon x value is not known. Therefore, to calculate that epsilon x value, one more formula I have given in the form of linear strain minus lateral strain minus lateral strain. म्हणजे काय हा epsilon x म्हणजे काय सांगतोय? The strain induced in x direction is equal to sigma x upon E. This is the linear strain because sigma x represent stress in x direction and आपण काढतोय काय strain in x direction. Therefore sigma x upon E, this is the positive value. Okay, so this is the linear strain. पण राहिलेल्या दोन डायरेक्शन मधला जो काय स्ट्रेन असतो तो काय असतो? It is lateral strain. Therefore we have to take negative sign because remaining all the dimensions are decreases. x डायरेक्शन मध्ये आपला कुठला पॅरामीटर आहे? लेंथ आहे. ओके, तर लेंथ त्या ठिकाणी इन्क्रीज होणार आहे. But remaining two directions B and D, they are decreasing. Therefore, mu into sigma y upon E and minus mu into sigma z upon. So this is the formula for the epsilon x. So one by one, put all the values. Epsilon x is equal to sigma x upon E. So sigma x is equal to 68.63 divided by 200 into 10 raised to 3 minus mu 0.3 into sigma y 60.72 divided by 200 into 10 raised to 3 minus 0.3 into 40.48 divided by 200 into 10 raised to 3. So here you will get epsilon x. This calculation is very important now. Epsilon x value, this calculation is very, very important.
(1.91 into 10 raised to minus 4).
Okay, 1.91 into 10 raised to minus 4. One answer I got. What about others? Please check whether it is same or different. I will write here 1.91 into 10 raised to minus 4. This is epsilon x value. Others, please check. Do the separate calculation of 68.63 divided by 200 into 10 raised to 3. That's a separate calculation करा. Okay. दूसरी टर्म आहे 0.3 into 60.72 divided by 200 into 10 raised to 3. Do the separate calculation. तसंच तिसऱ्या टर्मचं सेपरेट कॅल्क्युलेशन करा and then you have to do the addition and subtraction wherever subtraction is there or wherever addition is there, like this. If you are in the calculator, sometimes there is a facility. As it is, we are writing, we are inserting bracket at left side, bracket at right side, and sometimes one bracket we are forgetting, and you will get the different answer. And the different answer we are writing as a calculation. So step by step, do the separate calculation for each and every term. And then at the end, we have to do the addition and subtraction. Yes, 1.91 into 10 raised to minus 4. Everyone has got. You can apply your own way how to do the calculation, but answer should be same. It should not be wrong. It should be correct. You can apply shortcuts if it is possible to you. If shortcuts are not possible, do the separate calculation for each and every term. And then at the end, you have to do the addition, subtraction, multiplication, wherever it is required. Yes, now everyone is sending means you are doing the calculations without any mistake. 1.91 into 10 raised to minus 4. This is the strain in the x direction. This is the strain in x direction. Strain in x direction. So this we have calculated. We are having the formula. One more formula, epsilon x is equal to delta L upon EL. So now put epsilon x value here. 1.91 into 10 raised to minus 4 is equal to delta L. We have to calculate original length is 190. Therefore, those who have calculated epsilon x use another formula of epsilon x in the form of change in length upon original length and find out the change in dimension as a delta L.
So
What is the change in dimension?
Change in length 0.0363 mm.
363 mm. Okay. So this is the change in length. Please check your answer also. Or you can send answer in the chat box. 0.036 mm, correct. 0.036, 0.0362, 363. All answers will be accepted, no problem. So how to calculate the change in dimension? So for that purpose, we have to remind both the formulas. Epsilon x formula for the epsilon x calculation and delta L formula or second epsilon x formula for the delta L calculation. दोन्ही फॉर्म्युले तुम्हाला माहित असणं गरजेचं आहे. आणि epsilon x आपण कसा डिफाइन केलाय दॅट आय हॅव टोल्ड सिग्मा x अपॉन e दिस इज द लिनियर स्ट्रेन. पण राहिलेल्या दोन डायरेक्शन मध्ये लॅटरल स्ट्रेन असल्यामुळे आपण त्याला काय केलंय म्यू न मल्टिप्लाय केलंय आणि निगेटिव्ह साइन काय इंडिकेट करतंय तर देयर इज अ डिक्रीज इन डायमेन्शन. कारण epsilon x काढताना आपण काय अझम्पशन करतोय की फोर्स इज अप्लाइड इन x डायरेक्शन ओनली. मग जरी फोर्स एक्स डायरेक्शन मध्ये असेल तरी पण राहिलेल्या दोन डायरेक्शन मध्ये पण एक प्रकारचा स्ट्रेन इंड्यूस होतो आणि तो स्ट्रेन पण आपल्याला कन्सिडर करावा लागतो बिकॉज बॉडी इज 3 डायमेन्शनल. म्हणून ते आपण निगेटिव्ह घेतलेत बिकॉज देयर इज अ डिक्रीज इन डायमेन्शन आणि ते लॅटरल असल्यामुळे सिग्मा वाय आणि सिग्मा झेड ला आपण म्यू न मल्टिप्लाय केले. दॅट फॉर्म्युला विल गेट चेंज ड्यूरिंग epsilon y calculation. Similarly, epsilon z calculation. But you have to understand the basic meaning. सिग्मा x अपॉन e हा epsilon x काढताना कशामुळे घेतला तर दिस इज लिनियर आणि राहिलेले दोन लॅटरल. Someone mic is on. Yes, Shivraj, any problem?
No, sir.
Okay. Okay, delta L we have calculated. Now we have to use the formula of epsilon y. So we are having epsilon y formula. Tell me the basic formula in the form of dimension. Which parameter is present in the direction of y? L is over. Now B and D. Which parameter is present in the direction of y?
X and Z.
In the direction of y, out of length, width and depth, which parameter is there? That we have to calculate from epsilon y. Length is present in x direction. We have calculated by using the epsilon x. Now by using epsilon y.
Dimension.
Length into width.
Length into
L
Width.
into
here we have not calculated the area. In the direction of y, which parameter is present from length, width and depth?
Width.
Width.
Width, sir.
Width. You can check from the figure. What I told, y direction means vertical direction. मग vertical direction मध्ये कुठला पॅरामीटर आहे?
Height.
Height.
Height. Then how it is width? Width is present in which direction?
Z.
Width.
Z direction. So please keep in mind, मी sign convention तुम्हाला सांगितलेले आहेत. Length is present in x direction. Height किंवा त्याला आपण depth म्हणतो, it is present in y direction and z direction मध्ये तुमचा width हा पॅरामीटर असणार आहे. मग what formula I have to write here for the epsilon y? Delta L is over now. Then epsilon y is equal to, in the form of change in dimension, what I have to write? Epsilon y is equal to,
Sir, formula na?
I am asking only formula. Basic formula I have written. I have given in the previous lecture. Epsilon y is equal to change in dimension upon original dimension. But which dimension?
Sir, sigma y by e minus mu sigma
This
x
is
by
the another formula to calculate the epsilon y. This is the another formula to calculate the epsilon y. I am asking the formula in the form of change in dimension upon original dimension. जसा epsilon x is equal to delta L upon L आहे, तसा epsilon y काय असणार आहे?
Delta D upon D.
Delta D upon D. This is I am asking. Because हा जर फॉर्म्युला तुम्हाला माहित असेल तर तुमचा epsilon y काढून काही उपयोग होणार नाही. तुम्हाला तर epsilon y is equal to delta B upon B आहे का delta D upon D आहे का delta L upon L आहे, हे जर तुम्हाला क्लिअर नसेल तर तुम्ही delta D व्यवस्थित काढू शकणार नाही. This is the basic formula. Delta D upon D. Why delta D? कारण y डायरेक्शन मध्ये ज्यावेळेस आपण स्ट्रेन काढत असतो त्या ठिकाणी y डायरेक्शन मध्ये तुमचा कुठला पॅरामीटर आहे तर डेप्थ किंवा त्यालाच आपण हाईट म्हणतो. सो दिस फॉर्म्युला शुड बी ॲट युअर टिप ऑफ टंग. मग ह्याच्यानंतरचा दुसरा फॉर्म्युला आपल्याला माहित असणं गरजेचं आहे. कुठला? इप्सिलॉन y. नाउ टेल मी, इप्सिलॉन y इन द फॉर्म ऑफ सिग्मा x, सिग्मा y अँड सिग्मा z. काय येणार आहे सांगायचं? सिग्मा y इज इक्वल टू, इप्सिलॉन y इज इक्वल टू
sigma y by e
sigma y upon e, okay,
minus mu sigma x by e
mu sigma x upon e, correct,
minus mu sigma z by e.
by e. Okay, so this is the formula. What is the change in epsilon x and epsilon y? epsilon x काढताना पहिल्यांदा सिग्मा x घेतला होता कारण तो लिनियर आहे आणि राहिलेले दोन हे लॅटरल आहेत. तोच कन्सेप्ट पुढे अप्लाय करतोय. इप्सिलॉन y काढताना पहिल्यांदा सिग्मा y घेतला, मग राहिलेले दोन डायरेक्शन कुठले आहेत? x आणि z. त्या काय झाल्या? लॅटरल झाल्या. म्हणजे इप्सिलॉन y काढताना आपण असा अज्युम करतोय की फोर्स इज अप्लाइड इन y डायरेक्शन. ओके, मग फोर्स जर y डायरेक्शन मध्ये असेल तर त्या डायरेक्शन मधला स्ट्रेन म्हणजे लिनियर झाला आणि राहिलेले दोन डायरेक्शन कुठल्या राहिले? y सोडून मग x आणि z. मग त्या झालेला लॅटरल झाला. त्यामुळे त्या ठिकाणी सिग्मा x आणि सिग्मा y ला आपण म्यू न मल्टिप्लाय केले आणि मायनस तर राहिलेले दोन डायमेन्शन. आता सिग्मा y डायरेक्शन मध्ये तुमचा डेप्थ हा पॅरामीटर आहे, त्यामुळे त्या ठिकाणी डेप्थ ही इन्क्रीज होणार आहे. ओके, इप्सिलॉन y काढताना जसं इप्सिलॉन x काढताना आपण सांगितलं होतं की लेंथ इन्क्रीज होणार आहे आणि विड्थ आणि डेप्थ डिक्रीज होणार आहे. ओके, तसं इप्सिलॉन y काढताना डेप्थ ही इन्क्रीज होणार आहे आणि राहिलेले लेंथ आणि विड्थ हे दोन पॅरामीटर काय होणार आहेत? डिक्रीज होणार आहेत. ओके, नाउ we have to put all the values here. Sigma y 60.72 divided by 200 into 10 raised to 3 minus mu 0.3 into sigma x 68.63 divided by 200 into 10 raised to 3 minus 0.3 into 40.48 divided by 200 into 10 raised to 3. Now tell me the epsilon y value. How sigma x we have calculated? Same process we have followed, फक्त आपण टर्म काय केलेत? वेगवेगळ्या लिहिलेत as per the epsilon y. Epsilon y, one answer I got
1.39 into 10 raised to minus 4.
1.39 into 10 raised to minus 4. Okay, one answer I got. Okay, then what about other? What about other answers? 1.40, no problem, it is also accepted. 1.39 into 10 raised to minus 4 or 1.40 into 10 raised to minus 4. All answers will be accepted. Received answers from 4. What about others? Do the proper calculations. Yes, 1.39 into 10 raised to minus 4. Everyone has got the same answer. (1.39 into 10 raised to minus 4). If you have calculated epsilon y, then use the another formula of epsilon y. Now, epsilon y already we have defined delta d upon d. So epsilon y 1.39 into 10 raised to minus 4 is equal to delta d. We have to calculate, that is change in depth, and original depth we are having 65. Therefore, delta d is equal to, if you have calculated
9.03 into 10 raised to minus 3.
9.0
3 into 10 raised to minus 3
minus
mm.
3, which is equal to, how it is written, let us see, 0.00903 mm. If you write 9.03 into 10 raised to minus 3 mm, that answer is also accepted. But if we have to remove that 10 raised to minus 3, how it should be written, that also we have to represent here. 9.1 into 10 raised to minus 3, no problem. 9.11, that answer is variable because how many parameters we are considering for the calculation. 9.1 means 0.009 or 0.0091903. That all the answers will be correct, no problem. Understand the procedure how to calculate the change in dimension. कुठलं जर चेंज इन डायमेन्शन आपल्याला फाइंड आउट करायचं असेल तर त्याचे दोन फॉर्म्युले आपल्याला माहित असणं गरजेचं आहे. इप्सिलॉन x चे 2 फॉर्म्युले, इप्सिलॉन y चे 2 फॉर्म्युले आणि इप्सिलॉन z चे 2 फॉर्म्युले. अँड ते फॉर्म्युले माहित असताना x means which parameter, y means which parameter, and z means which parameter, that also we have to keep in mind. X means length, length is present along x, so epsilon x is equal to delta L upon L. Y means depth or height, therefore epsilon y is equal to delta d upon d, कारण y म्हणजे vertical axis आहे, vertical direction आहे, आणि त्या डायरेक्शन मध्ये डेप्थ आहे. आणि राहिला तिसरा, फ्रंट साइड आणि बॅक साइड ऑफ द सेक्शन, इन्क्लाइन्ड सिग्मा z, आणि त्या डायरेक्शन मध्ये कुठला पॅरामीटर आहे तर विड्थ, ज्याला आपण b म्हणतो. Yes, 9.03 into 10 raised to minus 3. Everyone has calculated. I received only 4 to 5 answers in the chat box. 1.39 everyone has received, but other change in depth or change in height, 9.03 into 10 raised to minus 3. If you have calculated, those who have calculated the change in depth, they can go for the further calculation, epsilon z. 9.03, 9.035, no problem, all the answers will be there. Now tell me the epsilon z formula now. Epsilon z in the form of change in dimension upon original dimension. Can anybody? Epsilon z is equal to change in dimension upon original dimension. Which parameter is present in the z direction?
Width.
Delta B upon D.
P.
Delta b
Change
upon b.
original width.
Change in width upon original width. ज्याला आपण b ने इंडिकेट करतोय, स्मॉल b ने. बघा डेल्टा एल तर ऑलरेडी काढलेला आहे, डेल्टा डी पण ऑलरेडी काढलेला आहे, त्यामुळे राहिलेला हा फक्त आपला विड्थ असणार आहे, डेल्टा b upon b. Okay. Now, second epsilon z formula to calculate the epsilon z. Tell me. Second epsilon z formula in the form of sigma x, y, and z.
Sigma z by E minus
Okay.
mu sigma x by E minus mu sigma y by E.
Correct. I have given this formula in your list and how it is coming. आता एप्सिलॉन झेड काढतो म्हणजे आपण काय असाइन करतोय की फोर्स इज अप्लाइड इन झेड डायरेक्शन. मग त्याच डायरेक्शन मध्ये इंड्यूस झालेला स्ट्रेन पण कुठला असणार आहे, लिनियर. त्यामुळे इथं सिग्मा झेड अपॉन ई ही टर्म सेपरेट घेतलेली. मग राहिलेलं डायरेक्शन दोन कुठल्या, एक्स आणि वाय. आता एक्स आणि वाय डायरेक्शन मध्ये फोर्स अप्लाय केलेला नाही, पण त्या डायरेक्शन मध्ये पण एक प्रकारचा स्ट्रेन येतो. त्यामुळे तो स्ट्रेन कुठले कन्सिडर करायचे तर लॅटरल स्ट्रेन कन्सिडर करायचे. त्यामुळे सिग्मा एक्स आणि सिग्मा वाय ला आपण काय केले, म्यू न मल्टिप्लाय केले. आणि ही निगेटिव्ह साइन म्हणजे काय सांगते बघा, देयर इज अ डिक्रीज इन डायमेन्शन. म्हणजे आता इप्सिलॉन झेड हा पण बी डायरेक्शन मध्ये किंवा बी ह्या पॅरामीटर मध्ये अप्लाय केला, त्यामुळे ह्या ठिकाणी विड्थ वाढणार आहे. पण राहिलेले दोन पॅरामीटर लेंथ आणि डेप्थ काय होणार आहेत, डिक्रीज होणार आहेत. दॅट्स व्हाय वी हॅव टेकन द निगेटिव्ह. नाउ पुट द व्हॅल्यूज epsilon z. So 40.48 divided by 200 into 10 raised to 3 minus mu 0.3 into sigma x. 68.63 divided by 200 into 10 raised to 3 minus mu into sigma y. 60.72 into 200 into 10 raised to 3. Tell me the epsilon z. Here I will write
8.02 into 10 raised to minus 6.
8.02. Answer is somewhat different. Just I will check epsilon z.
8.37
8.02
into 10 raised
into,
to
8.37
it should be 8 point
into
something.
10.
Yes, 8.37, 8.02. Then in another answers, so 9.108 into 10 raised to minus 3. This is different, epsilon z. Srihari, please check your answer, epsilon z. 9.108. I think this is the calculation of only last term. 9.108 into 10 raised to minus 3. This is the calculation of last term only. 8.37 or 8.02. That answer will be correct. Whatever answer you have received in your calculator, that you have to send. So I can verify all the answers. And if any another answer is different, then immediately I will check it. Yes, 8.37 into 10 raised to minus 6. 8.37 into 10 raised to minus 6 or 8.02 into 10 raised to minus 6. Maximum times 8.37 into 10 raised to minus 6 answer you have received. If you have calculated epsilon z, then use the formula once again. Epsilon z is equal to delta b upon b. So 8.02 into 10 raised to minus 6 is equal to delta b. We have to calculate. Original width is given 65. So final answer I will write here. Delta b is equal to, what is the answer? Delta b. If you have calculated, yes,
5.213 into 10 raised to minus 4 mm.
10 raised to minus 4.
0.0005213 m.
Here I will write delta b is equal to 0.0005213. Please check or verify your answers after the calculation of epsilon z. Epsilon z is correct for all. 8.37 or 8.02 into 10 raised to minus 6. This is correct. Now we have to use another epsilon z formula in the form of change in dimension upon original dimension. मग कुठले dimension change होते त्याच्यानुसार आपण फॉर्म्युला लिहिलेला आहे. डेल्टा बी अपॉन बी. इप्सिलॉन झेड ची व्हॅल्यू त्याच्यामध्ये पुट करा. ओरिजिनल विड्थ दिलेला आहे 65 mm ती पुट करा and find the change in b. You will get in the form of 10 raised to minus 4 like that. 5.44 into 10 raised to minus 4. So some of you got 5.21, some of you got 5.44. That answer is variable because your epsilon z is variable, but no problem, it is accepted. 5.44 means into 10 raised to minus 4. If we have to replace it, then how to write that? I have written here 0.000544 mm. 5.44 into 10 raised to minus 4 mm. Write down the unit also. This is very important. .44 into 10 raised to minus 4. If you write as it is, and if you write down the unit 5.44 into 10 raised to minus 4 mm, that answer also accepted, no problem. But if possible, try to write down in the form of 0.0000544 mm like that. So it will be the change in dimensions. Therefore, instead of representing in the 10 raised to minus 4, we have to write down in the proper point values. That means if you check all the dimensions, change in dimensions, that dimensions are very negligible. Delta L is 0.036 mm, delta D is equal to 0.0090 mm, and delta B is also very negligible. That is 0.00054 or 521 mm. All the change in dimensions are very small. That means that much maximum deformation is not taking place. Okay. So this is the last problem based on the type number 5, where we have calculated volumetric strain also, change in volume also, and as well as change in dimensions. But to calculate the change in dimensions, which 6 formulas are required, that we have to keep in your mind. Epsilon x, 2 formulas are required, epsilon y, 2 formulae, and epsilon z, 2 formulae. One epsilon x formula in the form of change in dimension upon original dimension, that is delta L upon N. Epsilon y, delta D upon D. Epsilon z, delta B upon B. And दुसरे राहिलेले 3 फॉर्म्युले epsilon x, epsilon y, and epsilon z in the form of sigma x, sigma y, and sigma z. ज्याच्यामध्ये लिनियर स्ट्रेन मायनस लॅटरल स्ट्रेन मायनस लॅटरल स्ट्रेन असा कन्सेप्ट. मग जो पॅरामीटर तुम्ही काढता, जर तुम्ही epsilon x काढत असेल तर सिग्मा x त्या ठिकाणी लिनियर असणार आहे, राहिलेले 2 लॅटरल असणार आहे. If we are calculating epsilon y, at that time sigma y is linear and sigma x and sigma z lateral. If you are calculating epsilon z, at that time sigma z is linear, remaining two are lateral. And why it is multiplied by mu? Because lateral. And why it is negative? Because they are decrease in dimensions. Okay, everyone has understood this problem, how to calculate the change in dimensions and how to use the formulas of epsilon x, y, and z for this calculation. Have understood everyone? Anybody is having any problem?
Yes, sir.
What about others? Anybody is having any problem? You can unmute from your side and you can ask if any question. Have you understood the type number 4, problems on calculation of volumetric stress, volumetric strain, change in volume, and change in dimensions? Very simple. List of the formula you should keep in your mind and you have to solve it. So you can give the replies in the chat box so I can clear the things that everyone has understood and we can go further. If you have not understood, you take your time, unmute from your side and ask me immediately. We will clear the doubts here only. Yes, everyone is giving the reply. Yes. Okay, good. So very simple and straightforward numericals are there. So you have to keep this list of the formula in your mind because now your exam is online. It is MCQ based questions, and in that MCQ based questions, these formulas are very important. These formulas are also asked as MCQ questions. They are mentioning the condition of uniaxial, biaxial, and triaxial. And for the uniaxial, biaxial, and the triaxial conditions, we have to identify the formula of uniaxial. 4 options will be given. And from that 4 options, we have to find the proper answer in the form of formulae. So you have to keep all the formulas at your tip of tongue. You can make the list of the formulas separately, chapter-wise list of the formulas. I have given the list of the formulas whenever we are starting the new type. If possible to you, you make the list separately and it becomes very good notes for your further study, for your gate study, for your further technical parts, if you are making list of the formulas separately. Okay, so with this we have finished this particular type number 4, that is problems based on the calculation of volumetric stress, volumetric strain, and the change in volume calculation and change in dimensions. Okay, and now we will start the last type of this particular chapter number 1. You can write down the heading: relation between Young's modulus E, modulus of rigidity G, bulk modulus K, and Poisson's ratio mu. So little bit introduction we have discussed in the theoretical discussion of this particular chapter. ज्यावेळेस आपण चॅप्टर स्टार्ट केला होता त्या ठिकाणी आपण प्रत्येक यंग्स मॉड्युलसच्या डेफिनेशन डिस्कस केल्या होत्या. प्रत्येक यंग्स मॉड्युलची एक कॉमन डेफिनेशन आहे, स्ट्रेस अपॉन स्ट्रेन. पण ई ला कुठला स्ट्रेस अँड स्ट्रेन आहे, जी ला कुठला स्ट्रेस अँड स्ट्रेन आहे, आणि के ला कुठला स्ट्रेस अँड स्ट्रेन आहे, that we have to remind. Can anybody tell me? Young's modulus is equal to stress upon strain, but which stress and which strain? Young's modulus is equal to which stress and which strain?
Linear stress and linear strain.
Linear stress upon linear strain, correct. Then what is the formula for the modulus of rigidity? Which stress upon which strain?
Shear stress and shear strain.
Shear strain upon shear strain. And for bulk modulus K, it is very simple. Bulk modulus K.
Volumetric stress upon volumetric strain.
Correct. Volumetric stress upon volumetric strain. This bulk modulus K factor is applicable maximum for the 3-dimensional bodies. ज्यात आपण टाइप नंबर 4 चे प्रॉब्लेम आता सॉल्व्ह केले, ज्याच्यामध्ये सगळ्या बॉडी 3-डायमेन्शनल होत्या. त्या ठिकाणी तिन्ही डायमेन्शन चेंज होतात, म्हणजे त्या ठिकाणी त्या बॉडीचा व्हॉल्यूम चेंज होत असतो. मग जर व्हॉल्यूम चेंज होत असेल तर त्याच्यामधला स्ट्रेन हा व्हॉल्यूमेट्रिक स्ट्रेन असतो आणि त्याच्यामधला स्ट्रेस हा व्हॉल्यूमेट्रिक स्ट्रेस असतो. जर अशा जर व्हॅल्यू आपल्याला काढायचं असतील तर त्या ठिकाणी आपण we can use the bulk modulus K for the further calculation. Okay, so this is the basic definitions of Young's modulus E, which is also called as a modulus of elasticity, modulus of rigidity, ज्याला आपण shear modulus पण म्हणतो, आणि तो कॅपिटल C ने पण आपण इंडिकेट करतो. ओके, and bulk modulus K and Poisson's ratio mu. Okay, so here I will write down all the relations. You can write down the heading: relation between Young's modulus E, modulus of rigidity G, bulk modulus K, and the Poisson's ratio. So already I have given that relations in the previous chapters as a theoretical point, but as we have to solve the numericals now, so once again I will give the list of the all the relation between all the elastic constants. You are having these derivations also. How these derivations will be defined? But whatever the small derivations are there, that derivations we will take. Other derivations we will skip because now the exams are online, so the derivation parts will not be asked in the online examination or in your MCQ examinations. So we will skip this particular derivation, and maximum focus we are giving on the list of the formulas and their numericals. And ह्या शेवटच्या टाइप मध्ये 101% 2 to 3 problems are there as a MCQ questions. ओके, फॉर्म्युल्यावर असू द्या किंवा याच्यामध्ये प्रॉब्लेम सॉल्व्ह करायचा, याच्यावर पण एमसीक्यू क्वेश्चन तुम्हाला एक स्मॉल 2 ते 3 स्टेप मध्ये उत्तर येईल अशा पद्धतीचा पण एक स्मॉल प्रॉब्लेम ह्या टॉपिकवर 100% विचारला जातो. सो वी हॅव टू गिव्ह मॅक्सिमम फोकस ऑन देअर रिलेशन्स अँड देअर सोल्युशन्स. डेरिव्हेशन्स आर देअर बट इट इज नॉट रिक्वायर्ड. I have mentioned the derivations in the notes, but here we will not taking whatever the small derivations are required as far as your online examination is considered or MCQ questions. That derivations we will take, or maybe in the further remaining chapters. But for this derivation is not required. So write down first heading: relation between E and K. Relation between E and K, that is E is equal to 3K in bracket 1 minus 2 mu. So write down this formula in your notebook. Then second, relation between E and G, or it is also called as a capital C. So E is equal to 2G in bracket 1 plus mu, or E is equal to 2C in bracket 1 plus mu. Okay. Then third, relation between all elastic constant E, G and K. So E is equal to 9 kg divided by 3k plus G is equal to 9 kg divided by G plus 3k. Here you can write down capital G is equal to capital C. And fourth important formula is required. Mu is equal to lateral strain upon linear strain. So take this all the four formulas in your notebook. Write down the heading: relation between Young's modulus E, modulus of rigidity G, bulk modulus K, and the Poisson's ratio. And write down the first heading: relation between E and K, because only three parameters are present in the first relation. E आणि पहिल्या रिलेशन मध्ये इथे E आहे, दुसऱ्या बाजूला K. Mu is the constant, forget about mu. Then second relation E and G, ज्यालाच आपण capital C पण म्हणतो. So E is equal to 2G in bracket 1 plus mu. And last third relation is relation between all the three elastic constant, ज्या ठिकाणी तिन्ही पण आहेत. G पण आहे, K पण आहे आणि E पण आहे. 3k plus G or G plus 3k, both are same. This all the three relations should be at your tip of tongue. Based on this 101%, one MCQ will be there. Question दिला असतो तुम्हाला, the relation between Young's modulus E and modulus of rigidity G. मग त्या ठिकाणी चार ऑप्शन असतात. E is equal to 2G in bracket 1 plus mu, E is equal to 4G in bracket 1 minus 2 mu, E is equal to 3G in bracket 1 plus 3 mu, E is equal to G in bracket 1 minus mu. So like that, four options are given, and out of that we have to choose the correct option. मग तो ऑप्शन जर तुम्हाला करेक्ट चूज करायचा असेल तर दिस थ्री रिलेशन शुड बी ॲट युअर टिप ऑफ टंग. हे तुमचे तिन्ही रिलेशन हे तोंडपाठच असले पाहिजे. त्या ठिकाणी डेरिव्हेशन आपल्याला लिहायचं नाही. डायरेक्टली वी हॅव टू सिलेक्ट द करेक्ट ऑप्शन. कुठलं रिलेशन करेक्ट आहे. मग काही वेळा रिलेशन देताना हे कॅपिटल जी मध्ये दिलं असेल ऑप्शन किंवा कॅपिटल सी मध्ये दिले असेल. 2G असेल किंवा 2C असेल, दॅट विल बी सेम. ओके. तसंच इकडच्या बाजूला पण E is equal to 9kc डिवाइड बाय 3k plus C असं पण तुम्हाला ऑप्शन दिलेलं असेल. सो डोंट बिकम कन्फ्युजन. G म्हणजेच कॅपिटल C आहे. Okay, so you have to remind this all the relations. Based on this MCQ question and MCQ problem is also there. Problem is very simple. Only we have to understand the statement and we have to solve it. Write out the three headings: relation between E and K, relation between E and G, and relation between E, G, K. And last common formula is also required. Mu is equal to lateral strain upon linear strain. Yes, everyone have taken this particular list in your notebook. Have taken list of the formulas in your notebook along with their relations.
Yes, sir.
Okay. So take this all the formulas, those who have not taken, in your notebook. So these relations are very important. Okay. I hope you have taken this list in your notebook. Okay. And now based on this, directly we are having the formula numericals. Very simple and the straightforward numericals are there. Just we have to read the statement carefully and we have to understand which relation we have to use for the calculation. याच्यामध्ये प्रॉब्लेम मध्ये कुठल्याच प्रकारची दुसरी व्हरायटी नाही. फक्त कुठल्या रिलेशन साठी कुठले गिव्हन पॅरामीटर दिलेले आहेत and which unknown parameters we have to calculate. Based on that we have to select the relation. तीन रिलेशन मध्ये आपल्याला कुठले रिलेशन सिलेक्ट करायचे that we have to understood first from the statement and then we have to go for the solution. Okay, so 2 to 3 problems are there that we will solve based on this last type. Okay, so read the statement carefully. See, a bar of 30 mm diameter means it is circular in cross section, subjected to pull of 60 kilonewton, subjected to pull of 60 kilonewton. Okay, and a major extension of length is 0.1 mm for 200 mm length. So one bar having 30 mm diameter आणि त्या बारवर काय झालेला आहे तर 60 किलोन्यूटनचा पुल फोर्स. पुल मीन्स टेन्साइल और कॉम्प्रेसिव्ह. पुल मीन्स टेन्साइल और कॉम्प्रेसिव्ह. टेन्साइल, पुल मीन्स टेन्साइल and push means compressive. So please keep in mind. Pull means tensile, pulling force. म्हणजे आपण ओढतोय त्याला. So this is tensile and a major extension of length is 0.1 mm and 200 mm in length. Then what is that 0.1 mm? Can anybody? What is this 0.1 mm?
Delta L.
Delta L. What about others? 0.1 mm delta L. Whether it is correct?
Yes.
बघा काय झालंय ह्या बारवर 60 किलोन्यूटनचा पुल फोर्स ऍक्ट झाल्यामुळं त्याचं एक्सटेन्शन झालेलं आहे. बघा टेन्साइल फोर्स आहे त्यामुळे त्या ठिकाणी लेंथ ही तुमची वाढणारच आहे आणि ह्या 60 किलोन्यूटन मुळे किती लेंथ वाढली आहे ती दिली आहे 0.1 mm. कुठल्या लेंथ साठी 200 mm लेंथ. म्हणजे ओरिजिनल लेंथ ही 200 mm आहे आणि 60 किलोन्यूटन फोर्स अप्लाय केल्यामुळे जे काय आतापर्यंत आपण डिफॉर्मेशन काढत होतो डेल्टा एल डेल्टा एल डेल्टा एल ते डेल्टा एल त्यांनी डायरेक्टली ह्याच्यामध्ये दिलेलं आहे. म्हणजे आफ्टर ऍप्लिकेशन ऑफ 60 kilonewton force the change in length is 0.1 mm and original length is 200 mm. Okay, and change in diameter 0.004 mm. जसं 30 mm original diameter दिलेला आहे that change in diameter is 0.004 mm. Now please tell me 0.004 mm this is a change in diameter, whether that change in diameter is increases or decreases. Change in diameter is increases or decreases. What about others? I want answer from everyone. Change in diameter is increases or decreases. So for that purpose, what I will do, I will draw the figure. This is the bar. This is the circular bar subjected to 60 kilonewton force. This is the original length 200 mm. This is the diameter. Now from this figure, please tell me change in diameter is increases or decreases as per the direction of 60 kilonewton.
Decreases.
Yes.
Decreases. Everyone is agree with this? Change in diameter is decreases. Yes, change in diameter is decreases and whatever the change in length is taking place म्हणजे delta L जे असणार आहे ते increase होणार आहे because the force is applied in x direction आणि x direction मध्ये कुठला पॅरामीटर आहे तर लेंथ आहे आणि y direction मध्ये कुठला पॅरामीटर आहे तर diameter आहे. Okay, so this is the figure. The given parameters they have given. Find Young's modulus, Poisson's ratio and bulk modulus. म्हणजे यंग्स मॉड्युलस कॅपिटल ई ची व्हॅल्यू आपल्याला फाइंड आउट करायची आहे, पॉइसन्स रेशो म्यू पण फाइंड आउट करायचा आहे आणि बल्क मॉड्युलस के हा पण व्हॅल्यू आपल्याला काय करायचे फाइंड आउट करायचे. ओके, इफ वी विल राइट ऑल द गिवन पॅरामीटर्स. फर्स्ट, कैपिटल D is equal to 30 mm. Okay, P is equal to 60 kilonewton is equal to 60 into 10 raised to 3 Newton. Okay, delta L is equal to 0.1 mm and original length is equal to 200 mm. Okay, then delta D is equal to 0.004 and we have to calculate capital E mu and bulk modulus. Okay, capital E, mu and bulk modulus. Okay, so these are the parameters we have to calculate. Now which formula we have to use for the first parameter calculation? If I have to calculate the capital E, which
Change
parameter
in
we have to use? Here change in length is given, delta L is given. Can we use the delta L formula for our further calculation? Think about that. If I will write the first E we have to calculate, and for the calculation of E, if I will write down the formula, delta L is equal to PL upon A. Can we use this formula for the Young's modulus E calculation?
Yes, sir.
Yes, sir.
Because if you think about this formula, original force is given, length is given, cross sectional area we can calculate from the diameter, Young's modulus we have to calculate, and delta L is also given. So we can use this particular formula for our calculation. Therefore, what I will write, delta L is equal to 0.1 is equal to P 60 into 10 raised to 3 into length 200 divided by area pi by 4 into diameter 30 square into capital E. Tell me the value of capital E. Very simple.
169.76 into 10 raised to 3 Newton per mm square.
169.76 into 10 raised to 3 न्यूटन पर mm स्क्वेअर. आतापर्यंत आपल्याला ही यंग्स मॉड्युलसची व्हॅल्यू प्रॉब्लेम मध्ये दिलेली असायची. आतापर्यंत ही यंग्स मॉड्युलसची व्हॅल्यू आपल्याला प्रॉब्लेम मध्ये दिलेली असायची, बट नाउ हियर वी हॅव टू कॅल्क्युलेट इट. व्हॉट अबाउट अदर्स आन्सर्स? Very simple formula, straightforward numerical. Only we have to use the list of the formulas for the calculation. Send your answers in the chat box. Delta L is equal to PL upon AE. Delta L is equal to PL upon AE. Delta L it is given, P is given, length is given, area is given as a diameter, and we have to calculate the Young's modulus E. 169.76 into 10 raised to 3 Newton per mm square. Yes, two answers I have received. What about others? This 169.76 into 10 raised to 3 Newton per mm square. This is the unit. It is not in gigapascal because all the parameters we have taken in mm. Therefore, it should be in Newton per mm square. (169.76 into 10 raised to 3 Newton per mm square). Still, some students are not sending their answers in the chat box. Everyone has to send the answer in the chat box for my verification. (169.76 into 10 raised to 3 Newton per mm square). Okay. Now, next. Second, mu. We have to calculate the Poisson's ratio of mu. Which formula we have to use for the mu calculation? Which formula we have to use for the mu calculation?
Mu is equal to
Lateral
lateral
strain.
strain upon linear strain.
Only one formula is having, and every time we are using it. Mu is equal to lateral strain upon linear strain. मग सांगा लॅटरल स्ट्रेनचा फॉर्म्युला काय येणार आहे, लिनियर स्ट्रेनचा फॉर्म्युला काय येणार आहे? कुठल्या डायरेक्शन मध्ये लिनियर स्ट्रेन असणार आहे आणि कुठल्या डायरेक्शन मध्ये लॅटरल स्ट्रेन असणार आहे? Yes, in which direction linear strain is there?
X direction.
In which direction? X direction. Okay, मग x डायरेक्शन मध्ये कुठला पॅरामीटर आहे? लेंथ आहे का डायमीटर आहे?
Length.
Length.
लेंथ. मग काय येणार लिनियर स्ट्रेनचा फॉर्म्युला काय असतो? कॉमन चेंज इन डायमेन्शन आपण ओरिजिनल डायमेन्शन. पण कुठलं डायमेन्शन चेंज होणार आहे लिनियर मध्ये? Which dimension is changing in x direction? लिनियर स्ट्रेन काढताना आपण काय सांगतोय की लेंथ इज प्रेझेंट इन एक्स डायरेक्शन. मग लिनियर स्ट्रेन हा कुठल्या डायरेक्शन मध्ये असणार आहे? एक्स डायरेक्शन मध्ये का वाय डायरेक्शन मध्ये?
X direction.
मग एक्स डायरेक्शन मध्ये आपला लेंथ पॅरामीटर आहे. मग काय फॉर्म्युला येणार आहे चेंज इन लिनियर स्ट्रेनचा? काय फॉर्म्युला येणार आहे सांगा? स्ट्रेनचा फॉर्म्युला तर माहित आहे, चेंज इन डायमेन्शन आपण ओरिजिनल डायमेन्शन. मग काय येणार आहे?
Delta L upon L.
Delta L upon L.
डेल्टा यल अपॉन यल. हा लिनियर झाला. देन व्हॉट इज लॅटरल? लॅटरल स्ट्रेन हा कुठल्या डायरेक्शन मध्ये? एक्स और वाय?
Y.
Y.
वाय डायरेक्शन मध्ये कुठला डायमेन्शन आहे? आपलं लेंथ आहे का डायमीटर आहे?
Diameter.
Diameter.
मग काय येणार आहे त्याचा स्ट्रेनचा फॉर्म्युला परत कॉमन चेंज इन डायमेन्शन आपण ओरिजिनल डायमेन्शन. पण कुठलं डायमेन्शन वाय डायरेक्शन मध्ये चेंज होत आहे?
Delta D upon D.
Delta D
Delta D
upon
upon
D. This formula or this understanding is very very important. Delta D upon D divided by delta L upon L हा कसा आला? आणि लॅटरल स्ट्रेनला आपण डेल्टा डी का घेतला आणि लिनियर स्ट्रेनला आपण डेल्टा एल का घेतला? दॅट अंडरस्टँडिंग इज व्हेरी व्हेरी इम्पॉर्टंट. का तर 60 किलोन्यूटन फोर्स इज अप्लाइड इन एक्स डायरेक्शन आणि एक्स डायरेक्शन मध्ये तुमचे दोन्ही डायमेन्शन पैकी फक्त एकच डायमेन्शन आहे. कुठलं? तर लेंथ आहे. आणि त्या ठिकाणी लेंथ ही तुमची इन्क्रीज होणार आहे. म्हणजेच जो काय लिनियर स्ट्रेनची डेफिनेशन काय? ज्या डायरेक्शन मध्ये फोर्स आहे त्याच डायरेक्शन मधला स्ट्रेन म्हणजे लिनियर स्ट्रेन. आणि ज्या डायरेक्शन मध्ये फोर्स आहे पण त्याच्या परपेंडिक्युलर डायरेक्शन मध्ये जर एखादा स्ट्रेन असेल तर त्याला आपण लॅटरल स्ट्रेन म्हणतो. बरोबर. त्यामुळं लिनियर स्ट्रेन हा हॉरिझॉन्टल डायरेक्शन मध्ये आहे आणि हॉरिझॉन्टल डायरेक्शन मध्ये फक्त लेंथच आहे. त्यामुळं लिनियर स्ट्रेनला आपण डेल्टा एल आपण एल घेतलं आणि राहिलेली व्हर्टिकल डायरेक्शन जे म्हणजे वाय डायरेक्शन, त्या वाय डायरेक्शन मध्ये तुमच्या रॉडचा डायमीटर आहे, तो डायमीटर काय होतोय? चेंज होतोय. पण आपण वाय डायरेक्शन मध्ये कुठला फोर्स अप्लाय केलाय का? नाही. इट इज नॉट अप्लाइड. तरी पण ते डायमेन्शन चेंज होतंय म्हणजेच इट इज lateral strain. So all the values are with you. Mu is equal to change in diameter 0.004 divided by original diameter 30 divided by delta L 0.1 divided by original length 200. Mu is equal to 0.26. Everyone has a representing answer in the chat box. 0.26 correct. 0.26 or 0.27. नो प्रॉब्लेम. आन्सर विल बी ऍक्सेप्टेड. कारण काही जणांचा आन्सर आलेला आहे 0.66. तेच अप्रॉक्सिमेटली आपण 0.27 असं पण घेऊ शकतो. 0.266 means it is approximately 0.27. So this is the calculation of mu. So whenever the mu is we have to calculate. So please think about the mu formula, lateral strain upon linear strain. मग lateral strain कसा काढायचा आणि linear strain कसा काढायचा? तर त्याच्यासाठी तुम्हाला स्टेटमेंट मध्ये चेंज इन डायमेन्शन मेन्शन केलेले असतात. जसं ह्या प्रॉब्लेम मध्ये चेंज इन लेंथ पण दिले आहे, ओरिजिनल लेंथ पण दिलेले आहे, चेंज इन डायमीटर पण दिलेला आहे आणि ओरिजिनल डायमीटर पण दिलेला आहे. मग त्याच्यामध्ये कुठला पॅरामीटर हा लिनियर आहे आणि कुठला पॅरामीटर हा लॅटरल आहे? दॅट वी हॅव टू अंडरस्टूड फ्रॉम द फिगर. ज्या डायरेक्शन मध्ये फोर्स आहे त्या डायरेक्शन मधला जो काय पॅरामीटर आहे तो पॅरामीटर लिनियरला कन्सिडर करायचा. पण ज्या डायरेक्शन मध्ये फोर्स नाही पण एक पॅरामीटर आहे तो तुम्ही काय कन्सिडर करायचा? तर लॅटरल कन्सिडर करायचा. 0.266 or 0.27. Both the answers will be accepted. No problem. Okay. Now, second is calculated. What they have asked? Third, K, bulk modulus K. Which relation we have to use? Which relation we have to use for the K calculation? Out of our three relations, G तर ह्याच्यामध्ये दिलेलं नाही.
3k
A
in
is equal
bracket
to
1
3.
minus 2 mu.
EK is equal to 3K in bracket 1 minus
2 mu.
Put the value 169.76 into 10 raised to 3. Already we have calculated 3 into K as it is 1 minus 2 into mu is calculated 0.26. Write the equation in the form of K. K is equal to 169.76 into 10 raised to 3 divided by 3 in bracket 1 minus 2 into 0.26. Tell me the value of K.
120.91 into 10 raised to 3 Newton per mm square.
Newton per mm square. Everyone please check your answer with this. Send your answer in the chat box. .91 into 10 raised to 3 Newton per mm square. So simply we have used one relation between Young's modulus E and K, and we have calculated the things. Means to calculate the value K, we have to calculate E and we have to calculate mu. जर आपण E काढला नसता आणि mu पण काढला नसता तर आपल्याला K ची व्हॅल्यू काढता आली नसती. So for the calculation of K, initially we have to calculate the E and we have to calculate the mu. आतापर्यंत in all the statements, the Young's modulus is given. Take E is equal to 200 gigapascal. Take mu is equal to 0.3. Take mu is equal to 0.25. Take mu is equal to 0.26. But in this last step, sorry, in the last type, we have to calculate that parameters. For the calculation of mu, how the lateral and linear concept is important and how the figure is important, that understanding is very important. Figure पण काय important आहे तर कुठल्या डायरेक्शन मध्ये फोर्स आहे तो आपल्याला फिगर नुसार कळतंय. So for that purpose, we have to remember the definition of linear. Linear means in the direction of force. Lateral means perpendicular to the direction of force. Linear means perpendicular. Lateral means parallel to force. This is very important. 120.99 into 10 raised to 3 Newton per mm square. This is the value of K. Still some students are not sending the answers. Everyone has to send the answer. .99 into 10 raised to 3 Newton per mm square. This is the value of K. All answers are same after the verifications. Okay, then next problem. A metal has modulus of rigidity 4 into 10 raised to 4 Newton per mm square. One metal, त्या मेटलची एक मटेरियल प्रॉपर्टी आपल्याला दिलेली आहे ते म्हणजे 4 into 10 raised to 4 Newton per mm square and bulk modulus 8 into 10 raised to 4 Newton per mm square. That means whatever the metal is given, that metal having modulus of rigidity 4 into 10 raised to 4 Newton per mm square and bulk modulus म्हणजे दोन मटेरियल प्रॉपर्टी आपल्याला दिलेल्या आहेत and find E and mu and find E and mu. So in given only two parameters are there. One is G 4 into 10 raised to 4 Newton per mm square, and K 8 into 10 raised to 4 Newton per mm square. So this is the very simple problem they have given. Now here, if we have to calculate the capital E, and if we have to calculate the capital mu, so initially if we have to calculate the capital E, think about the relations, which relation we can use. कारण म्यू तर आपल्याला दिलेला नाहीये. जर एक म्यू ची व्हॅल्यू दिलेली असती तर आपण E is equal to 3k in bracket 1 minus 2 mu or E is equal to 2g in bracket 1 plus mu ह्या दोन्हीपैकी कुठलं पण रिलेशन वापरलं असतं आणि आपण E ची व्हॅल्यू काढली असती. बट म्यू ची व्हॅल्यू दिलेली नाही. Yet which relation we have to use out of the three relations?
9kg by 2k plus g.
Yes, correct. If you think about the relations, तिन्ही इलेस्टिक कॉन्स्टंट मधलं एक रिलेशन आहे ज्याच्यामध्ये म्यूचा पॅरामीटर नाही. दॅट रिलेशन इज सी E is equal to 9kg divided by 3k plus g or 9kc divided by 3k plus c. So this is the common relation. ह्या रिलेशन मध्ये कुठल्याच प्रकारचा म्यू पॅरामीटर आपल्याला लागत नाही. So out of this relation, the value of g is given, value of k is given. So simply put capital E, we have to calculate. 9 is as it is, k value is given 8 into 10 raised to 4 into g means c value is given 4 into 10 raised to 4 divided by 3k means 3 into k value 8 into 10 raised to 4 plus g value 4 into 10 raised to 4. What is the E?
102.85 into 10 raised to 3 Newton per mm.
102.85 into 10 raised to 3 Newton per mm square. Everyone, please check your answer. Send your answers. Very simple. 102.85 into 10 raised to 3 Newton per mm square. Direct relation we are having in all elastic constants. सगळ्या इलेक्ट्रिक कॉन्स्टंटचे एक रिलेशन आहे ज्याच्यामध्ये म्यू पॅरामीटर नाही. पहिले दोन रिलेशन जर आपण थिंक केले, E is equal to 3k in bracket 1 minus 2 mu and E is equal to 2g in bracket 1 plus mu. ते दोन दोन कॉन्स्टंट मधलंच रिलेशन आहे, प्लस म्यू इज ऑल्सो प्रेझेंट. बट थर्ड रिलेशन इज रिलेशन बिटवीन all three elastic constant. Relation between all three elastic constant. And from that we have calculated the capital E. Now if we have to calculate the mu, second parameter, if we have to calculate the mu as a second parameter, ह्या ठिकाणी तर change in dimension दिलेले नाही, lateral strain upon linear strain, then which we have to use?
3k in bracket 1 minus 2.
Any relation, कारण आता E ची व्हॅल्यू आपल्याला माहित झालेली आहे. Any relation we can use. See, E is equal to 3k in bracket 1 minus 2 mu. I can use this relation also for the mu calculation, and E is equal to 2g in bracket 1 plus. Find from the both. 102.85 into 10 raised to 3 is equal to 3 into k. What is the value of k? 8 into 10 raised to 4. 8 into 10 raised to 4 in bracket 1 minus 2 mu. Okay. So what I will do? 1 minus 2 mu I will keep as it is. 102.85 into 10 raised to 3 divided by 3 into 8 into 10 raised to 4. 1 minus 2 mu ही टर्म ब्रॅकेट मध्ये आहे, त्यामुळे ती ब्रॅकेट मधली टर्म आपण एका बाजूला ठेवली आणि राहिलेल्या टर्म इकडच्या बाजूला घेतल्या. तर इथे म्यूची व्हॅल्यू तुम्हाला काय येते बघा. फाइंड दिस टर्म 0.28. जस्ट आय विल चेक. 0.28 करेक्ट. 0.28. Here calculation part is very important.
0.2857.
0.2857, correct. You can take 57 also. 0.2857. 1 minus 2 mu ही टर्म एका बाजूला घेतली. राईट साइडचं कॅल्क्युलेशन काय आहे? 102.85 into 10 raised to 3 divided by 3 into 8 into 10 raised to 4. राईट साइड कॅल्क्युलेशन केलं. गेटिंग. हे मायनस 2 म्यू परत काय केलं? राईट साइडला घेतलं. इकडची व्हॅल्यू परत इकडे नेली. हे 2 म्यू इकडे घेतलं. म्हणजे 1 प्लस हे आलेला आन्सर केलं आणि परत डिवाइड बाय 2 केलं तर तुम्हाला 0.2857 आलं पाहिजे. तसंच इकडचं पण बघा. 102.85 into 10 raised to 3 is equal to 2 into g. What is the value of g? 4 into 10 raised to 4 in bracket 1 plus mu. तर काय करायला लागेल? 1 plus mu एका साईडला ठेवायचं. 102.85 into 10 raised to 3 divided by 2 into 4 into 10 raised to 4. Then what is the value of mu by using the second relation, whether it is same or different? Either using the relation between E and K or either using relation between E and G for the mu calculation. The mu is same or different, just for your verification. Do the calculation and then tell me answer.
Same, sir.
Same. How much? 0.2857.
0.285625.
0.28 I will write only. If you compare the mu value from both the calculation, it will same. So need not require to make this calculation two times in the examination. Single time it is accepted. Just for your verification and just for the comparison whether answers are same or different. So that's why we have made. Is everyone has calculated 0.28? Only few students they have represented the answer in the chat box. If you have received a single times, that answer you have to represent. How E is calculated from all the three elastic constant, and for the calculation of mu, any relation we can use in between EK or in between EG. What is the answer of others? Only 4 to 5 students have represented the mu answer. Everyone has to represent. You have to do the calculation and then represent the answer. Don't send the answers only. Zero 0.28. It is correct. 0.28. This is the Poisson's ratio mu. Okay, and then last problem we will take based on this type number 6. Again, it is very simple. What is the first problem we have solved? What is the first problem we have solved? Based on that only, the problem is here. In the first problem, there is a circular bar, and here the rectangular section they have given. So read the statement. Let us see. A metal bar of 40 mm by 40 mm in section subjected to axial compressive load of 50 kilonewton. One metal bar is there, and that metal bar of 40 mm by 40 mm in section subjected to axial compressive load. Whatever the load is applied, it is compressive and its magnitude is 500 kilonewton. The contraction of 200 mm gauge length. The contraction of 200 mm gauge length. Gauge length means this is the original length of the bar. Then what is about 40 mm by 40 mm? What is it is given? 40 mm by 40 mm means which values are given? Length is separately mentioned. Means what is mean by 40 mm by 40 mm?
Width
Yes?
and thickness.
Yes,
Area.
width and thickness means B into D. 40 mm by 40 mm means width B and depth D. Sometimes the value will be given 200 mm by 40 mm by 40 mm like this. 200 mm by 40 mm by 40 mm. म्हणजे हा काय झाला L into B into D. बट हिअर ह्या स्टेटमेंट मध्ये लेंथ वेगळीकडे मेन्शन केलेले आहे आणि राहिलेले दोन पॅरामीटर बी आणि डी हे वेगळ्या ह्याच्यामध्ये मेन्शन केलेले आहेत. ओके, सो द गेज लेंथ इज 200 mm. The contraction of gauge length is found to be 0.6 mm. Means what it is given? 0.6 mm. What is given? Contraction. Delta L. Now here please tell me whatever 0.6 is there and here the one word is they have mentioned contraction means length is increases or decreases.
Decrease.
Decreases.
Why?
Contraction, compression.
एकच वर्ड फक्त इथे दिलाय ऍक्सियल कॉम्प्रेसिव्ह लोड. ह्याच्यावरच तुम्हाला समजलं पाहिजे की त्या ठिकाणी तुमची लेंथ ही डिक्रीज होणार आहे. म्हणजे 0.6 mm इज द चेंज इन लेंथ, पण ती चेंज इन लेंथ म्हणजे डिक्रीज इन लेंथ असणार आहे. ओके, and the increase in thickness is 0.4 mm. 0.04 mm. बघा लेंथ डिक्रीज झालेला आहे पण दुसरा पॅरामीटर काय झालेला आहे इन्क्रीज झालेला आहे. पहिला प्रॉब्लेम आपण बघितला तर त्याच्यामध्ये टेन्साईल लोड होता आणि डायमीटर होता, तर त्या ठिकाणी लेंथ इन्क्रीज झाली होती 0.1 mm आणि 0.004 mm हा डायमीटर काय झाला होता डिक्रीज झाला होता. का तर लोड टेन्साईल होता. पण ह्या ठिकाणी एक्झॅक्ट अपोजिट आहे. अप्लाय झालेला फोर्स हा कॉम्प्रेसिव्ह असल्यामुळे लेंथ ही डिक्रीज झालेली आहे आणि थिकनेस काय झालेली आहे इन्क्रीज झालेली आहे. That is change in thickness they have given. Find the value of mu and 3 elastic constant. Means we have to calculate E also, G also and K also. Okay, so this is the statement. So if I will write down the given, so here 40 mm by 40 mm, this is the cross sectional area because the force is applied in x direction. Force is applied in x direction आणि ज्यावेळेस आपल्याला एरिया AX काढायचा असतो त्यावेळेस तो काय असतो कशाचा प्रोडक्ट असतो तर B into D. एरिया AX means B into D. टाइप नंबर 5 मध्ये आपण बघितलं होतं AX म्हणजे B into D, AY म्हणजे L into B and AZ means L into D. But here already 40 mm by 40 mm means B into D they have given. Original length is given 400. Change in length is given 0.6 in bracket capital C means it is under compression. Thickness capital D is equal to capital T is equal to capital B is equal to 40 mm. कारण दोन्ही डायमेन्शन सेम आहे. डेल्टा D म्हणजे चेंज इन डेप्थ 0.04 mm ज्याला आपण डेल्टा T पण म्हणतो कारण इथं थिकनेस वर्ड त्यांनी मेन्शन केलेला आहे. त्याला आपण डेप्थ पण म्हणू शकतो पण इथं वर्ड थिकनेस मेन्शन केलं त्यामुळे आपण डेल्टा T म्हणजेच डेल्टा D म्हणू शकतो. ओके, अँड वी हॅव टू कॅल्क्युलेट म्यू, we have to calculate E, we have to calculate G and we have to calculate K. We have to calculate K. Okay, if you have to draw the figure, so this is the 3-dimensional body कारण तीन डायमेन्शन दिलेले आहेत. तर लेंथ 200 mm, width 40 mm, depth 40 mm, force is applied as a compressive. So this is what is the magnitude of force 500 kilonewton. This is 500 kilonewton. Okay, and this is the cross sectional area we have to consider. Okay, so due to this compression length is decreases but the thickness is increases. Exactly opposite. The length is decreases but thickness is increases, and also they have mentioned in the statement the increase in thickness is 0.04 mm and contraction of gauge length म्हणजे decrease झालेली लेंथ काय असणार आहे 0.6 mm असणार आहे. Okay, so this is the figure is given in front of you. Okay, the force, compressive force is given, dimensions are given, change in dimensions are given. If the first parameter we have to calculate mu, which parameter we have to use, sorry, which formula we have to use for the mu calculation?
lateral
Which
strain.
lateral strain.
only one formula we are having, कारण ह्या फॉर्म्युला मध्ये किंवा ह्या स्टेटमेंट मध्ये चेंज इन डायमेन्शन दिलेले आहेत. जसा पहिला प्रॉब्लेम आपण सॉल्व्ह केला तसंच तिसरा प्रॉब्लेम आहे, फक्त त्याच्यामध्ये सर्क्युलर बार दिला होता, ह्याच्यामध्ये 3 डायमेन्शनल बार दिलेला आहे, त्याच्यामध्ये टेन्साइल फोर्स होता, ह्याच्यामध्ये कॉम्प्रेसिव्ह फोर्स आहे. ओके, आणि इकडे चेंज इन डायमेन्शन म्हणजे डेल्टा एल आणि डेल्टा टी दिलेला आहे, म्हणजेच वी हॅव टू यूज म्यू इज इक्वल टू लॅटरल स्ट्रेन अपॉन linear strain. Then tell me the formula for the lateral and linear strain. In which direction linear strain is there as per the figure? So this is the horizontal direction and this is the vertical direction. Force is applied in which direction? Horizontal or vertical? Force is applied in which direction? X or Y?
X.
X. ओके, मग X डायरेक्शन मध्ये कुठला पॅरामीटर आहे? लेंथ आहे का विड्थ आहे का डेप्थ आहे?
Length.
X मध्ये कुठला पॅरामीटर आहे? लेंथ, विड्थ और डेप्थ?
Length.
Others, length is present. Then in which direction linear strain will be there? In X direction or Y direction?
Y.
लिनियर स्ट्रेन हा कुठल्या डायरेक्शन मध्ये असणार आहे? X डायरेक्शन मध्ये का Y डायरेक्शन मध्ये?
X.
Y direction. How it is Y direction? Can you elaborate? Why it is Y direction? Linear म्हणजे काय? What is the definition of linear? What is the definition of linear strain? Y डायरेक्शन मध्ये कसा लिनियर स्ट्रेन असेल? हाउ इट इज ऍप्लिकेबल फॉर द Y डायरेक्शन? त्या डायरेक्शन मध्ये फोर्स आहे का? 500 किलोन्यूटन फोर्स हा कुठल्या डायरेक्शन मध्ये अप्लाय झालेला आहे? X डायरेक्शन मध्ये. मग Y डायरेक्शन मध्ये कसा लिनियर स्ट्रेन असेल? लिनियर स्ट्रेनची डेफिनेशन काय? ज्या डायरेक्शन मध्ये फोर्स अप्लाय झालेला आहे त्याच डायरेक्शन मधला फोर्सला आपण लिनियर स्ट्रेन म्हणतो. मग फिगर मध्ये जर तुम्ही बघितलं तर 500 किलोन्यूटन फोर्स इज अप्लाइड इन X डायरेक्शन. मग कुठल्या डायरेक्शन मध्ये लिनियर असणार आहे आणि कुठल्या डायरेक्शन मध्ये लॅटरल असणार आहे?
X मध्ये लिनियर आणि Y मध्ये lateral.
Okay, X मध्ये linear and Y मध्ये lateral. Then tell me the formula for the linear strain in the form of change in dimension upon original dimension.
Delta L upon
Formula
L.
for delta L upon L.
Linear strain.
And then what is lateral strain? Change in dimension upon original dimension. Y डायरेक्शन मध्ये आता कुठला पॅरामीटर आहे सांगा? लेंथ आहे का विड्थ आहे का डेप्थ आहे किंवा थिकनेस आहे? इन Y डायरेक्शन म्हणजे व्हर्टिकल डायरेक्शन मध्ये तिन्ही डायमेन्शन पैकी कुठलं डायमेन्शन आहे? लेंथ आहे का विड्थ आहे का डेप्थ आहे? डेप्थ, ज्याला आपण थिकनेस म्हणतोय. आणि दॅट चेंज इन थिकनेस इज ऑल्सो गिव्हन. बघा, ही चेंज इन थिकनेस 40 mm. 40 mm पासून त्याची चेंज इन थिकनेस झालेली आहे 0.04. म्हणजे ही वाढलेली थिकनेस आहे, म्हणजे व्हर्टिकल डायरेक्शन मध्ये थिकनेस वाढलेला आहे, म्हणजे पण त्या डायरेक्शन मध्ये फोर्स आहे का? नाही. Therefore that strain will be considered as a lateral. Then tell me the formula in the form of change in dimension upon original dimension.
Delta D upon
Lateral
D.
strain delta D upon D or delta H upon H. This is the formula. How to define lateral and linear हे तुम्हाला समजलं पाहिजे. If you are make the mistake here, your answer will be wrong. लिनियर स्ट्रेन म्हणजे तुम्हाला फिगर मध्ये दिसतंय की X डायरेक्शन मध्ये फोर्स अप्लाय केलेला आहे, त्यामुळं X डायरेक्शन मधला स्ट्रेन हा लिनियर असणार आहे. पण X डायरेक्शन मध्ये कुठला पॅरामीटर आहे? लेंथ. म्हणजे त्या ठिकाणी चेंज इन लेंथ आपण ओरिजिनल लेंथ म्हणजे लिनियर स्ट्रेन झाला. बट थिकनेस इज प्रेझेंट इन Y डायरेक्शन. थिकनेसचं डायमेन्शन तुम्हाला कसं दिलेलं आहे फिगर मध्ये, व्हर्टिकल मध्ये दिलेलं आहे, पण त्या व्हर्टिकल डायरेक्शन मध्ये फोर्स अप्लाय झालेला नाही. फोर्स हा फक्त हॉरिझॉन्टल डायरेक्शन मध्येच आहे, पण ती थिकनेस पण चेंज झालेला आहे, म्हणजे इन्क्रीज झालेला आहे, म्हणजे त्या डायरेक्शन मधला स्ट्रेन म्हणजे काय झाला, लॅटरल स्ट्रेन. सो नाउ पुट द व्हॅल्यूज. Mu is equal to 0.04 divided by 40, change in length 0.6 divided by original length is given as a 200. Tell me the value of mu.
0.33.
0.33. 0.33. Everyone please do the calculations and tell me the answer. 0.33. 0.33. Understand the concept once again for the linear and lateral. Once again, write down the definition of linear. Linear means strain in the direction of force, and lateral means strain in perpendicular to the direction of force. Linear means direction of force and lateral means perpendicular to the direction of force. मग ही डेफिनेशन अप्लाय केल्यानंतर परत आपले डायमेन्शन बघायचे. फोर्सच्या डायरेक्शन मध्ये कुठलं डायमेन्शन आहे, तर लेंथ आहे. बघा इथं मी फोर्स दाखवलाय तुम्हाला 500 किलोमीटर, याला पॅरलल तुमची काय लेंथ आहे, लेंथ पण हॉरिझॉन्टल आहे, पण जी काय हाईट थिकनेस आहे ती थिकनेस ह्या दिलेल्या फोर्सला परपेंडिक्युलर आहे. बघा दिस इज द हाईट, दॅट्स व्हाय इट विल बी कन्सिडर्ड ॲज ए लॅटरल. The next parameter we have to calculate the Young's modulus E. Which formula we have to use for the Young's modulus E calculation? We are having the delta L formula.
PL upon A.
PLA upon A. So delta L is equal to 0.6 is equal to P. 500 into 10 raised to 3 into length 200 divided by area 40 into 40 into Young's modulus E. What is the Young's modulus E?
104.16 into 10 raised to 3
104.16 into 10 raised to 3 Newton per mm square. Please check your answers. 106.16 into 10 raised to 3 Newton per mm square. We have to use simple formula of deformation. Delta L is equal to PL upon E, and from that we got the Young's modulus E value. Everyone please check your answer whether it is coming or not. One 0.16 into 10 raised to 3 Newton per mm square. One 0.16 into 10 raised to 3 Newton per mm square. If you have calculated, then go for the further calculation. So once again, we have to calculate the remaining two elastic constant. So first of all, I have to calculate the K. So we are having the relation E is equal to 3K in bracket 1 minus 2 mu. So 10.16 into 10 raised to 3 is equal to 3K in bracket 1 minus 2 into 0.33. So K is equal to 104.16 into 10 raised to 3 divided by 3 in bracket 1 minus 2 into 0.33. K answer
102.123.
102.116 into 10 raised to 3 Newton per mm square.
102.116
into 10
into
raised to
10
3
raised.
Newton per mm square.
Please check your answer. And second relation for the G calculation we have to use E is equal to 2G in bracket 1 plus 10.16 into 10 raised to 3 is equal to 2G as it is. Someone mic is on, please mute. G is equal to 104.16 into 10 raised to 3 divided by 2 in bracket 1 plus 0.33. Check your answer. 102.12 into 10 raised to 3 Newton per mm square. K value is correct. Those who have calculated, it is correct. Others, please send your answer in the chat box. And those who have calculated K value, they can go for the G calculation. Tell me the value of G.
39.16 into 10 raised to 3.
39.15 into 10 raised to 3 Newton per mm square.
39.16 or 39.15 Newton per mm square. Don't calculate direct G value. First of all, calculate K value, those who have not calculated. And then go for the G calculation. Procedure for the both is same. We have to put the E value and we have to put the mu value. But for that purpose, we need to remind the relations. If you made the mistake 1 minus 2 mu च्या ऐवजी 1 plus 2 mu घेतलं किंवा 1 minus 3 mu घेतलं किंवा 3k च्या ऐवजी 2k घेतलं, it will wrong. So that relation should be at your tip of tongue. Calculate both the answers properly and send the answers in the chat box so I can verify all the answers here. 39.15 or 39.16 into 10 raised to 3 Newton per mm square as a G value and K value 102.11 into 10 raised to 3 Newton per mm square. Okay, so with this we have finished this particular chapter number 1, that is simple stress and strain. With this particular last type, relation between all the elastic constants and their problems, our chapter is finished. If anybody is having any problem from total chapter, you can ask. After this lecture, immediately I will send the handwritten notes of this chapter number 1 on our WhatsApp group. Also, I have already sent MCQ booklet of all chapters. So once again, I will send that MCQ booklet on the WhatsApp along with notes of the chapter number 1. Already study material sheet is also shared with you. So you have to refer that particular notes. Maybe in the next lecture, next 2 to 3 lectures, whenever our next lecture will be there, maybe on Monday or maybe on Tuesday, you are having the chapter test number 1. Test will be conducted online. MCQ based question will be there. Test of 20 marks on the chapter number 1. So you can refer the MCQ booklet. The test is of for 1 hour. I will send the link on the WhatsApp group. You have to attempt it and you have to submit. This chapter test is very important. Based on this, your term work will be given. So you have to attend that particular chapter test, and attendance of that particular lecture and that test will be given based on the solving that particular quiz. So in advance, I am telling, I will send the message also for the test, but anyhow, tomorrow is the maybe holiday. Anyhow, whenever our next lecture will be there, if 2 hour lecture is there, 1 hour teaching will be there and 1 hour test will be there. So please keep in mind, 1 hour test and 1 hour teaching. Or if I will get any extra lecture in that period also, I will send the test link on the WhatsApp group. So please be prepared, be ready for that. Refer the notes, refer your notes, whatever you have written, refer my notes, whatever I am sending on the WhatsApp group, refer the MCQ booklet, whatever I am sending on the WhatsApp. And still, if anybody is having any problem, you can ask me anytime for the doubts. I will clear it. Okay. So with this particular last point and this last numerical, we have finished this particular chapter number 1. Everyone has understood the chapter number 1, simple stress and strain, and whatever the basic concept, definitions, important formulas, all the types of variety of the problems, type 6. In this chapter only this much variety is there. In remaining 7 chapters, that much variety is not there. Only 1 or 2 types of variety problems are there. This is very basic and simple chapter is there. Therefore, variety is up to the 6. Everyone has understood? समझले सगळ्यांना chapter number 1?
Yes,
have cleared
sir.
all the concepts,
Yes, sir.
have taken all the things in your notebook. I want answer from each and every students, those who are attending. Have understood the things? If you have not understood, you can ask, you refer the notes. I will send after finishing this chapter immediately. Study it properly. This is the very basic chapter and a very important chapter. Be ready for next MCQ test 1 or chapter test number 1 also. I will send the Google form, and through that Google form you have to attempt the test. Yes, once again I am asking, everyone has understood the things? All are giving the reply yes. Okay, still if you are facing any problem anytime, you have to ask me anytime. You can send the message, you can send the screenshot, whatever you have not understood, I will explain it once again. Okay, one more homework problem is there based on this particular type number 6. So that homework problem I will send on the WhatsApp group. Statement of the problem I will send on the WhatsApp group. You have to solve that particular problem and send that solutions on the WhatsApp group. Those who have not solved the previous problem based on the type number 5, you have to solve it, and that answer you have to send. And whatever type number 6, that is relation between elastic constant, that you have to solve, and you have to send the solution to me. Okay, so with this we have finished this particular chapter number 1. In the next lecture we will start with the chapter number 2, and we will conduct the test also. Okay, so with this today we will stop here. Thank you very much.